I gave you a number like this, just using a real simple fraction, you could rewrite this as the sum of terms. Now again, I made it so you could factor, you could remove a common factor from the numerator, but if it's asking you to write it as the sum of terms, what that's saying is you're going to take whatever your denominator is, and you're basically going to distribute it into each term individually. Rewriting as the sum of terms is asking you to take your fractional denominator and pull it out and convert it into, again, multiplying by the reciprocal. So dividing by 2 is just like taking this whole quantity, 10x minus 5, and multiplying it by the reciprocal of 2, 1/2, which if you distributed through would give you 10x over 2 minus 5x over 2. So really what you would be doing here is you would be distributing the 2 through. And you apply this division of 2 to each individual term in that fraction. Okay, so if I give you something to this effect, and I ask you to rewrite this as the sum of terms, what it's asking you to do is take each individual term from the numerator. Okay, so you basically can start by just rewriting those terms, the exact expression, and then dividing each individual term by that denominator. What you would then do is simplify the fractions that remain. So here you have 5/2 x to the first. The x's cancel. Here you would have minus 3/2, and here the 2's would cancel. So minus, and usually it's going to ask you to write it in the form where there's no denominator or no variable written in the denominator. Now it exists there, but if we wanted to rewrite this with a base of x, what would our power have to be to show that it's in the denominator here? What power of x tells you your variable is in the denominator? Power of -1. Okay? So this is kind of the form it's asking you to identify. Okay? And so the last type of example that I want you to take a look at would be something like this. Okay? If you have something that has a radical mixed in with it, in order to apply or distribute this denominator into each individual term, you probably want to think of it in terms of its rational power. So the square root of x is x to the what power? Square root is power of 1 over 2. Remember, 1 over whatever the index happens to be. And then you'll do the exact same thing. So 5 minus 6x squared minus x to the 4th. You're going to divide each individual term by the same denominator, x to the 1/2. And so when you rewrite this, you will take 5x to the minus 1/2. The negative tells you the base is in the denominator. And then here, when you're simplifying the rest, put everything in terms of the same fractional denominator. So 2 and 1/2 here. 2 is how many halves? So if you think of it as 4 halves, you can now see that your answer is -6x to the, when you divide two numbers with the same base, what do you do with their powers? Subtract. 4 halves minus 1/2 gives you 3 halves. Minus here x to the, again, 4 is how many halves? Think of it in terms of the same fraction. 8 halves minus 1/2 leaves you with 7 halves. Okay, so when you're writing these, again, the rational powers mean, are these, which if any of these are polynomials? Okay. Is this a polynomial? A polynomial, can a polynomial have more than one term? Can it have just one term? Yeah, monomial, right? So monomial, binomial, trinomial. So classification-wise, we're looking at a, if this is a polynomial, we would call this a binomial. Okay, what do you know about the powers? I heard somebody read it. Okay, so a non-negative integral power means whole number, right? It can be 0. That's your constant. So is this is the only power of x? Is it a whole number? Yeah. So is this a polynomial? Yes. So this expression here is a polynomial. Negative power means not a polynomial. What about this? Again, fractions and negatives? No. Okay, so the only one out of all of these that is a polynomial is that first one. Okay, but this is what you'll do when it asks you to rewrite as the sum of terms. You're just going to distribute the denominator into every term from the numerator independently, and then you're going to simplify each individual fraction.